Hey guys, Jay at Brother Performance here. Okay, we get a lot of questions on this, and I recommend this piece to people if they're building a C6 for high power. This seems to be a question that people have, and well, why do I need that, and that sort of thing. So this here is what we call a high pressure forward piston. We make this for the C6, make it for the C4 also. And the reason for this is because, as the name implies, when you're making high pressure, which is required for higher power applications, or also if you're running a manual valve body or a trans brake valve body, where the pressure is fixed, so that means the pressure is high all the time. It doesn't taper off when you're not under heavy load like a auto shift valve body does. So if you're running a higher pressure valve body, or you're running, especially if it's fixed pressure, mainly I use these in fixed pressure. Auto shift, not as important because the pressure varies, but you do have to be careful because when you're putting shift kits and things, valve body kits, I don't want to mess up that copyright infringement there. Sorry, I always got to make that little dig. I hate it when people copyright words. I'm going to copyright Broader Performance, so you guys can't say that anymore. Anyways, so when you put these kits in and they raise the pressure in it, or you put these big boost valves in, what happens is this drum here, this forward drum where this goes into, it can break the top of it off where the snap ring groove is because it's kind of thin. Sometimes it'll actually crack and break this top pressure plate. A lot of times in these units you'll see the disc spring in here, they get broken. They'll break right around where all these cutouts are, and they'll be in 8 pieces or whatever when you take the drum apart. So this is what this is supposed to fix, and normally what people are doing is they're basically buying a billet drum. They're pretty expensive. I don't know, $700-800, probably more now. Who knows? I don't honestly ever use them unless somebody wants them, because I don't have trouble with the stock drum. And here's why I don't have the trouble with the stock drum. So I'm going to kind of try to show you how this piston works so you understand it. But so 2 things about it that you need to know. It's going to take the lip seal style ring on the outside. This is just a factory lip seal. I didn't do any nonsense where I make you buy a seal from us and charge you $50 for it. Just a stock one that goes in your kit. So for any 76 and up, the earlier ones didn't have a lip seal. They were a square cut, what they call a lathe cut seal. But all 76 and up overhaul kits will have this seal. Uses just the standard O-ring for the inner seal, so you're never going to be left looking for, a special seal or something during a rebuild. So that's a nice feature. The other thing about it is these pistons normally took a wire ring that went on here. I've just eliminated that. You don't need that wire ring. And if you're not sure what I'm talking about, I'll show you here. This is that wire ring that goes on the factory piston that would sit in a groove here. But a lot of people try to put this in and like, man, I can't get the snap ring on and all that. What's up? Well, just don't put this. We're just, this you're just going to discard. We don't need that anymore. So basically what happens and how this works. So this is just to prevent the drum from breaking or breaking pressure plates and things like that. So I've got a drum here. I put just the stock piston in, and then this one here you can see has the billet piston in it. And the reason for this is not to buy a billet part. It has nothing to do with it being billet or anything. It's easier to make a new one than it is to. I used to modify these old ones, but we just make them new now. And so it doesn't help that it's billet, but what helps is it changes the geometry of the drum. So basically this disc spring is it's a pry bar. It's a radial pry bar, if you will. I don't know what the terminology is, but if you look at the pivot point, you see where the wire ring runs right on the edge of these tangs. And in this drum, it runs in quite a bit more. It does initially apply at the end here, but as this progresses and it pressurizes, it moves the pivot point, and it's basically going to give you less clamping force, but which, you know, at first you think, well, geez, you know, high performance, I want more clamping force. On this particular drum, you actually want less. It's got way too much. This clutch pack is not generally an issue burning up. They do burn up once the disc spring fails, and especially if the pressure plate starts to crack, and certainly fails altogether if the top of the drum breaks off, obviously. So that's, you know, we're actually reducing the clamping force because, you know, it was one of these rare situations where you actually just have way too much. So I'm gonna, you won't really be able to tell much probably, but I'm going to put these on here, and I just have a pump I put together, and a lot of you guys that build these probably do this, put a pump together so you can do your air checks. So I'm going to apply air, and my shop air is running right around 100, 110, which is, you know, about half of what you run for a really high power application. So, you know, I want you to look at this and just try to envision this with double the amount of apply air on it. It's quite a bit more than what I have. So if you look at this move, and it moves quite a bit, and I don't have a lot of clearance in here, and don't put a lot of clearance in this drum, because if you see how that piston has to travel just to take up the clearance, and you're also getting some flex on that disc spring too. It kind of flexes a lot and then it kind of stops because it you know, as it progresses, it changes the leverage. And I've worked this out. This wasn't really a first draft or anything. I've experimented with this. So I'm just going to put this one on here, and honestly, at this pressure, at low pressure like this, because your units are going to run, minimum stock pressure was around 75, 80. We're running just a little higher than that, but this is pretty low pressure, and you're just going to see. I'm going to get some air. There we go. The Teflon rings sometimes don't like to air check. And you can see it's not moving a whole lot more than the other one at this pressure. But if you can try to picture twice the pressure, there's kind of no stopping it. Because of where this pivot point is, you know, you're all the way out here, and when you have this big piston here with 200 pounds of pressure, it's really going to drive this disc spring, and it's going to really be pushing on this clutch pack, and it just wasn't designed for that much pressure. I think this unit was probably designed for, or at least this system here on the forward drum, Ford probably figured a maximum of 180 pounds at very short intervals. So it won't even hold 180 pounds for long periods of time, or at least that, you know, I'm not saying it won't, but at least at, you know, if you're at that level for a long time, it's really going to wear this thing. And a lot of stock units, I see these springs broken and things. I don't really see the drums broken much in a stock unit, but the drums most definitely break when you're running a trans brake valve body or something. So this is why we've designed this piston here, and we do sell these, and sorry to say we're out of stock on them a lot. I make them in-house. It's made in USA, and man, I just run out of them. By the time I make a batch, they almost seem to be committed. So if you do see these for sale on the website, and you see that I actually have some in stock, and you're wanting to build your own unit for some power, go ahead and grab one. I promise you, you'll appreciate this piece. This is just one of the things that I've never seen anybody else do in this unit. And I really think that it helps a lot, and I don't have problems with the forward drum, and it's a lot cheaper than, like I said, buying a $700-800 drum these days. So anyways, I hope this kind of clears this up. A lot of people just didn't understand why I'm trying to sell them this piston. They're so focused on, well, I got to have red clutches and choline steels, and I got to put a power pack in it. Well, that, to me, that's all a bunch of BS. But that's well and good if you want to do that. But this, to me, here, and putting some pressure in the unit, this is going to make the difference, not some crazy coated steel plate or some fancy looking clutch plate. The OEM clutches are pretty damn good. You just got to work on the hydraulics of the system. So anyways, hope that helped, and appreciate you watching.